So today I have the pleasure of welcoming the ARC Prize 2025 first place top score winners, NVARC. I'm so excited to have you both here. Could you please introduce yourselves?
I'm Jean-Francois Puget, so if you want to pass a French test, or you can call me JF.
I am Ivan Sorokin. I'm based Finland in Helsinki.
Yeah, I'm based in France, and we both work for NVIDIA.
Well, it's such a pleasure to have you both on. We are so excited to share this story because it's been really cool to see your progress and your huge achievement. JF, we'll start with you. What do you do outside of Kaggle competitions? Like, what's your day job?
Actually, Kaggle competition is part of the day job. I manage and I'm part of a team called Kaggle, Kaggle Grandmaster of NVIDIA, who were hired to compete, so do competition like our prize, but also, and that's what you ask about, give back to NVIDIA, product teams, and partners what we learn in competition. So in competitions, we learn about state-of-the-art machine learning and AI in practice, not from papers, and we help projects how to build good models, how to evaluate them, what kind of tooling is useful, etc.
Very cool. How about you, Ivan?
I also am a member of Kaggle team. Primarily, I do competition, and I was fortunate to spend most of my time for our prize too.
And it paid off. You definitely made good use of that time. This is really exciting. This Kaggle Grandmasters of NVIDIA, or Kaggle, which sounds like Pokemon, I guess. It's a pretty special program. I mean, this is, you get paid to go off and compete and sort of bring learnings back to NVIDIA. And there's actually a sort of giving angle of this. So like, can you share, what happens with any prize money won through that Kaggle activity?
That's the flip side. So given we are paid to spend part of our time, not full time, but part of our time competing, and the flip side, to avoid conflict of interest, is any prize money we win, we give to charity. So we have a foundation at NVIDIA called NVIDIA Foundation, and any prize money, including our prize, which is good money, will go to some charity.
That's right. $25,000 is the top score, first place prize. So that is really wonderful. ARC Prize Foundation is also a nonprofit. So we're pretty happy to double the impact of the prize itself. It's really cool. Thank you all for the work that you do. I think it's pretty cool. It's a pretty special program. Has the team, the Kaggle team, been fairly winning? Have you all had success sort of in other competitions?
Yeah, Ivan, speak about the other win of the year.
Yeah, but I would say it's not always, but before ArcGI 2 prize started, another competition ended. It was AIMO 2. It's about a math Olympic competition when LLM solve mathematical problems. And I was member of a team from NVIDIA built from Kaggle plus specialized team, Nemo Reasoning, and we won this competition too.
Congratulations.
The prize was much higher, just for the record. For me, was about money. I learned a lot how to do synthetic data, how to do LLM fine-tuning, and I was eager to try all of these skills in ArcPrize.
The team won other competitions. One is Priority, which was a biology, biomedical, and the model is so good that now it's put in a platform built by CZII, so Chan Zuckerberg Foundation. But as Ivan said, we win some. We often get one of the team in top 10 in Gold Zone, but we don't win all the time. That's for sure. It's competitive. Machine learning is competitive. We don't win every time by far.
It's just amazing progress. And it really is just kind of a special arrangement within a larger, company. I guess for context, how did you both learn about ArcAGI and ArcPrize? How did it first get on your radar?
I saw the first Kaggle competition like 6 years ago. And I was frustrated I wanted to enter, or maybe I was intimidated. So I didn't. And I was a bit frustrated. So it was an ArcGI one. Top score was like 21%, I think, at the time. Then it disappeared. Apparently, it was held in a smaller format outside Kaggle. And last year, it appeared again. So I thought, okay, this reminds me of symbolic AI problem solving, which I did in my PhD a long time ago. So I said, I will build a symbolic problem solver. And I was able to solve like 60% of the evaluation data sets. Okay, let me submit. And I got a score of 0.
Oh,
Okay,
no.
I got it totally wrong. ArcGI is about learning at test time. You have to learn how to learn from few examples. I sprinted, did a 2D transformer, could not make it work, but my paper was part of the ones who got a prize. I tried to make it when I saw ARC2. I said, okay, I will try to make my model work, and it didn't manage, but it was few %, nothing. And then much later, Ivan pinged me, hinting that maybe we should team. So I would let him present his side of the story. And the end.
Yeah, I also tried ArcPrize 1 last year. I might be slightly better successful. I just was 61 or something like this. And I spent a lot of time on perception problem, how to represent this puzzle, maybe do some vision model and visual representation. It gives me a sense of this challenge. This year, I tried different stories. I learned last year a lot. And this year, I tried different approaches.
Yeah, that's a good teaser of where we're going next. You're starting with all these learnings that you mentioned from previous events. And it's cool, Jean-Francois, to hear about, your past, like you've been involved in the art community for quite a while. It sounds like back when Lab 42 and Francois Cholet were running competitions before ArcPrize last year started. Where do you start? You kind of have, previous winning strategies and solutions. You could kind of choose to ensemble those and optimize. You can come up with something radically new and novel. How did you decide to eat the elephant of solving ArcGI 2?
So for me, it's when Ivan hinted we should team that I came back. So Ivan, you should describe how you started this year.
I joined competition 5 months ago in June. As I mentioned, I switched from other competition when we apply reasoning model. LLM produced chain of thought, step-by-step reasoning about mathematical problems. And I was brave and maybe naive to apply the same techniques for ArcPrize. And I started my journey in ArcGI 2 with a reasoning model. I tried to apply some fine-tuning techniques up to reinforcement learning as well. But anything I try, it's always limited by data. And after about a month of experiments, I just switch my focus to synthetic data and make diverse, complex, high-quality synthetic puzzles. The last months of competition, you might notice my name on Leaderboard and later NVARC. It's because I had all my synthetic data and I applied this data for existing solution in previous year competition, recently published model. And my idea was feed this data into existing approach. Personally, I focused on architect solution. And later in competition, I asked Jean-Francois to make a team to make our solution more robust, built from different approaches. I assumed he has some knowledge and experience with small models. And it was a good experience. Without this team up, I don't think it will be successful. And
Yeah, I think you would have done well alone, but yeah, maybe in a different store. So when Ivan started saying maybe I should go back, my model, I wasn't sure I could improve it and wanted to try something else. And I saw this paper, tiny recursive models that make, 7 million model beating GPT-5 and this and that on ArcGIS. So it looks small, interesting, not as powerful as what Ivan already had, but in an ensemble, you don't need to have two powerful models. You can have a powerful one and a weaker one. If the weaker adds a bit, it's all benefit. So I said, okay, let me try. I told Ivan, let me work on TRM. If it's promising, we can team. So I started long, I don't remember, maybe 2 weeks before, no, I don't remember. So the difficulty was TRM was working nicely. Author reported a score of 7 or 8%, and then your team or prize reproduced, got a slightly lower score, but like 6.8 or something, which was promising for ensemble, but this required like 3 8H100 GPUs, so 3 nodes of 8H100 for one day, which is way more than on Kaggle. So all the work was how can we distill this into something that can run fast enough on Kaggle, like in 2 hours, to give the rest of the time to Ivan model by using the same test time fine-tuning ideas that I explored the previous year and which is now table stake. Could manage to get TRM score. So I did not submit it alone really because we did not have enough submission, but a late submission managed to score 10% with TRM in 2 hours. So it was interesting. Did not have that much in the end for the ensemble, but maybe with more time, it would have helped a bit more.
I think one thing that's really exciting about, what you both have mentioned is just this kind of the point of ARC Prize, which is sort of open progress. So, you mentioned the architects, winning solution last year, who, by the way, they won second place, top score this year. So props to them. And the Alexia, who wrote the TRM paper, has won the paper award this year, first place there. So it's just really beautiful to see, kind of the collaboration across different competitors and these novel new ideas that get added that just all of a sudden the scores will just jump up. That brings me to a question about, the sort of experience of the competition this year. So behind the scenes, we were kind of watching the leaderboard and, there were some people kind of making good progress, and this little team, NVARC, submitted a bunch, kind of what you mentioned, Ivan, when you first joined. And then there was this big many-month gap where there was just no submissions at all. And then all of a sudden, 9%, 10%, and then just bam, like ramps up and starts like doubling. And, it's like clearly like some kind of breakthrough happened. So number one, what was happening during the big gap with less submissions? And then what was that unlock that really led to, you all taking the crown in the end?
Most of the time I spend on data, on making synthetic puzzle, but I also try to apply this data for reasoning model. And that's why I didn't submit, because luckily results was not good enough to make submission. With all of this Kaggle constraint, it's really challenging. Apply reasoning model, step-by-step reasoning, even at Python code execution, it's just unrealistic. The good part of this research time, at the end of this month, I just sit on big chunk of data. And the last month, I took this data and apply for other solutions. That's why you see this climbing on the Leaderboard. Each day, I literally try to fix bugs or added more data or just tuning. Each day we had some hyperparameter to check. Last month was crazy.
Well, one thing, you say you reuse the architect solution. you modified it as well, not just reusing with more data.
Yeah. Compare with last year, we had more resources, not much, but still better. It's 4 GPU with L4. Last year, it was 2 T4, if I'm not mistaken. It's not much, but still more room for improvements. And indeed, I optimized architect solution and made it more better.
And you use different models also.
Yeah, different models. I can give you a quick overview what I've changed, but in general, all the many months I spent on data and making reasoning model unrealistic in this constraint, and I apply all my data for existing approaches.
That's really exciting. Yeah, the thing I was referring to is just through the Kaggle competition, there's a certain compute allowed, sort of runs on their cloud servers, and it was doubled between 2024 and 2025. So that right away left some nice, low-hanging fruit for improving past winning solutions. But you all did much more than that. And by the way, it's really refreshing to hear a team that says, I didn't bother submitting because I knew that the score wouldn't be much bigger, because it means you're not trying to probe the leaderboard.
To me, that's the one thing Kaggle teaches data scientists, to not overfit. On Kaggle, we learn how to evaluate models properly. I've been burned on Kaggle overfitting in my first competition, never did it again. So no, that's something, that's what differentiates top Kagglers from average data scientists. It's we learn how to not overfit. And I remember I saw François Chollet tweeting 2 days beforehand or something, select wisely, don't overfit, blah, blah. I knew other teams were overfitting. It happens in every competition. Not all other teams. Some other team would overfit. I was sure.
It's definitely interesting as a competition host to watch the scores split, so that you start seeing the public score kind of deviating away from the private set. But yeah, it used to be where people would literally hard code, hey, there's an ARC task that has a blue background, so check for that manually and then solve it. And that's not going to get us to AGI, right? That's not really like the point of the competition.
Even if they don't do it as explicitly, you submit. It's tempting to select the one with the best, to use the public score as a reward, and you tune for that. Whether or not, if you're not careful, you tune for that. We did not have time. We climbed quickly at the end, so we did not have time to overfit, I would say.
And that worked out brilliantly in the end. So maybe there's a lesson in there for everybody. You're talking about the models, but one thing that jumped out to me was this synthetic data. That sounds like a big factor for your winning solution. So what was that synthetic data? What kind of data are we talking about? Can you share more about that?
To make synthetic data, I search existing data sets for art puzzles, and I found one interesting data set named HARC. It includes comments from real participants who solve puzzles. There was about 1,700 participants, and dataset includes about 4,000 unique user comments for art puzzles. And I decided to take this data, mix them together, and based on these mixtures, produce a new puzzles. And my hope was when you combine two simple puzzles, you can have a more challenging puzzles.
That actually reminds me of, the creation process of ArcAGI too, is just sort of how many layers of abstraction there are. And it's interesting to see how things remain fairly easy for humans, but get harder for AI, the more you stack those kind of rules on top of each other.
I'd like to add something on the ZG. Many people say, the way to do well on ArcAGI is to generate code on the fly. And some did brute force attack on ArcAGI 1 that way. So you design ArcAGI 2 to make it more difficult, but still And the insight of Ivan, I would say, is to move code generation offline inside the data generation. So he does generate code, Python code, offline. We have time, can use big LLMs. And then we distill on a small model that is used for Kaggle inference. And that one doesn't generate code. That's why we could do well, because it has no reasoning, no code generation. All of this is done before, offline.
That's very clever.
Yeah, I think that's what our solution is about. Is to move the expensive compute offline and distill.
Yeah, that's a completely valid approach and quite brilliant, actually. Was there some insight that led to that, or was it just simply a matter of, hey, the compute is constrained on Kaggle, so we can't use it, but hey, these are very powerful models like that we should be able to leverage in some way?
Yeah, I made some changes in classical pipeline. You might heard about NVARC dataset. They also made quite large portion of synthetic puzzles, but they made it in one shot. Means they prompt LLM once and LLM produce a whole puzzle solution with input grid logic, transformation logic in one single LLM completion. I decided to split this pipeline into different stages. And when you split this complex reasoning into different stages, you can use different LLMs. You can validate each stage independently. You can do different validation, consistency check more accurately, and dataset quality, it's getting better. Initially, I use some open weights model, Quinn models, but later, when OpenAI released GPT OSS model, 120 billion, I decided to generate my synthetic data with this model, and quality get even better.
That's really cool. It's cool to hear the inside, decision making behind those choices. It does sound very iterative too. It sounds like you're kind of testing and seeing what the performance is. Some new model comes out, TRM kind of comes out. You say, what can we learn from this, and how can we apply it? Is that right?
The way to do well in a competition is to try a lot of things. So you need to be able to evaluate correctly. It's not about throwing things and see what sticks. Some do that, but it's more testing rigorously. So you know what you test, you know how to interpret the result, and if it's progress, then you keep and you test another idea. And it's all about testing quickly ideas and implementing them. So it's good when you have a long competition because you can test a lot of things. But it's all about testing quickly, I believe. Do you agree, Ivan?
Absolutely. Testing more ideas, team up with many people help even better.
Because there are more ideas when you team, you have cross discussion and cross-fertilization. So
yeah, I was just going to warn folks, there's a tricky thing with just the Kaggle registration where, once you join a team, you can't leave a team. And if, you can't kick someone off of your team either. So just, yes, team up with people, but maybe be discerning as you kind of make those decisions. It's probably easy for you two since you know each other and you've probably worked together in the past. But we've heard of some sticky situations where folks were working it out with their teammates.
I've been removed from a competition after winning a gold medal.
Oh, wow.
Because that's teammate cheated without telling.
That's such a bummer. That's got to be pretty hard because it's not your doing. It's nothing you can, it's just, like the choice and teammate, I guess, is all you did. But, oof. Well, I can tell you, I'm looking at the scores here for, I was going to ask, what were the results? Well, I can tell you the public score of the sort of winning submission that you all made. And yes, there were other last minute submissions that even did better than this, but the public score was 27.64 and the private score was 24.03. And just for RKGI2, that is very impressive progress for this year. I think other solutions, on the leaderboard, as we discussed before, didn't have that, impressive sort of score with the private side. So you really were undoubtedly the winner this year. How does it feel? Like, is sort of satisfying to just the thrill of the competition? How's that side, the experience feel?
It was hard to believe because we got this winning score 1.5 hours before the end of the competition.
Wow.
So we had something we thought was better, but it was still not finished. There was a queue. People were saying, oh, maybe my submission won't run in time. So we said, okay, let's submit the best we had from a couple of days ago. And we were watching, will it finish in time? Yeah, it was crazy. And when we saw the score, it was a surprise. We did not expect it to top, maybe become second, but yeah, it was a total surprise.
For me, a few weeks before the end, I would happy to have gold medal. Maybe 20 place would be good to me. But at the end, it was unexpected for me too. I can tell you how I realized we at first place. I remember I woke up after a couple of hours sleep. I checked Leaderboard and I can find NVARC on Leaderboard. What's going on? And I scrolling down, I can't find it. I thought maybe we removed or did something wrong. I see messages from Jean-Francois and I checked the first place and I see NVARC. Yeah, it was crazy. It just 2 hours before deadline.
That was scary. Thinking like, did JF cheat and I got disqualified? Just like looping back to his past. No, he did not.
The reason we did not want to submit that one, it's because on local evaluation, remember, we do a lot. We found that it had some variability in score. And we were finishing one that was more stable. But with a late submission, it scored the same. So I don't know on private, but so that's why we were we were unsure we would win even with this nice public score.
Yep, it's always a mystery, but it turned out to be good news in this case. We're going to hear, some themes from this year. Definitely this kind of refinement loop idea is something that was novel in 2025. 2024 was the year of test time adaptation, test time fine tuning, whatever you want to call this thing, which we actually saw kind of trickle into industry work. You saw chain of thought, and you could kind of see that as a version of this. And how do we improve sort of base LLM models? And that was kind of a big unlock. So JF, how did test time training, have an impact on your winning solution?
Yeah, so the general idea is, again, each puzzle in ARC AGI comes with some training example and then some test. And this training example on the test puzzles, you don't know. So you cannot pre-train a model. So whatever you do, even on the nice event data, it's not enough. So you need to make the model learn a bit enough to understand the specifics of the test puzzle so that it can solve it. This has a name, it's called transduction in machine learning research. It's an old idea, but it never was really applied. But here, ArcPrize and ArcAGI in general, benchmark, is really about how can a model adapt to few examples. So it's a bit like few-shot learning if you just use a LLM, a generic LLM. And for TRM, it just amounts to retrain a pre-trained TRM just on the test data, on the training example of the test data, and then applying it. So for TRM, it's quite straightforward. I would say there are some technical aspects because of the puzzle embedding, but this is a detail. It's about fine-tuning, so that's why we call it TTFT, fine-tuning the model on the training part of the test data. And it's key, it moves from 0 to 10%. If you don't do it, it's 0. It doesn't score. Doesn't solve anything. For TRM, huh?
Similar idea used in architect solution, and indeed this test time adaptation or fine-tuning kind of boost knowledge from pre-trained model. Pre-trained model still requires diversity in puzzle. That's my theory, that more synthetic data helps. But without this test time fine-tuning, it didn't work. Honestly, the last year competition, I didn't try it too. I was thought perception play the bigger role, and I should focus only on representation and on this part. But now I'm seeing results and test time adaptation playing much bigger role for this solution.
That's a perfect segue to the next question I wanted to ask you, which is what's next? You've had this success. You could always choose to continue pushing, with this same approach. You could try, something completely new and novel. Where are you most curious to kind of explore going forward?
It depends how competition will organize, what compute resources we will have. But for me, I think making more synthetic data will help, definitely. And applying reasoning model, I still believe in this research. My initial experiment showing reasoning step by step, apply tool calling, it's all help, but it requires much more resources.
I concur with Ivan. What he said are ways to improve the score. I would like to see if we can make reinforcement learning efficient enough to run in a Kaggle competition. Because that's also another angle that, there are plenty of examples in verifiable domains that it can help, and this is a verifiable domain. So, no, I can't speak too much about unpublished results, but with a lot of compute, it's useful.
Yes.
Can it be less useful with less compute? I don't know, but that's something I'd like to look at. And so maybe RKGI3 is a great test bed for reinforcement learning. I don't know. Maybe.
Makes sense to me. And it could be cool to see, themes emerging in 2026. This year went so fast. I can't believe we're already talking about 2026 like it's, a couple of weeks from now. And, NeurIPS is happening.
EO is less than a year ago, huh?
It's just blowing by. Never a dull day in the AI world, huh? It's just you blink and the whole world moves by. Well, last question for you both. And, Jean-Francois, you've given a bunch of great gems to folks about, competing in Kaggle and ways to kind of, traps to avoid. But specifically, RKGI is hard. It's a very limited amount of data. It requires this, real, test time sort of adaptation. It ain't easy. And it's, it's definitely not a solved problem. For people, looking at getting into future competitions, what advice would you give them?
Just try. So often now we are kind of applied machine learning experts, let's say, inside NVIDIA, and we have people coming, you think this would work better or that? Do both, and you see. It's an experimental, to me, machine learning is like experimental physics. Training a model is an experiment, and you learn from experiment. So you have to do stuff and learn from what you do. So to become good at competition, don't pick RKGI as your first competition. That may be a bit, or unless you're very skilled, you will do well at your first competition. But now is your competition on Kaggle or elsewhere. Do stuff, learn from the others, look at what works, what did not work, what you tried did not work, what you could have done differently. Learn from experience. It's about learning how to learn again, I would say.
It's a meta. It's like your model has to do the same thing, but you as the human also need to do this.
Exactly.
How about you, Ivan? Any advice?
On my side, I lucky to have access these NVIDIA resources, GPUs. I can do a lot of experiments. I thought understandable. It's totally a different story when you do it alone in single GPU. Maybe have some sponsors or some team up with other members who has access to GPUs.
We actually have a number of in-kind donors to our Prize Foundation, which offer service credits to help with training and things like that for our. I'll definitely link in the show notes resources there. But yeah, it's a pretty special thing. So final word to you both. Huge congratulations. It's so impressive what you've done. It was a really cool, exciting story that seems like it just came out of nowhere. But now that I know you're both experienced Kagglers from this KGMon team, big congrats. You should be very proud of your work. I'm excited to see also what the community does. They're going to read. I'll link to your write-up about your solution.
There will be tests in a week.
Torture, huh? This is the flip side of sharing. But I think you've got some fresh ideas, and I can't wait to see where you both go with it. So, NVARC team, congratulations on your huge success. Looking forward to seeing what happens next. Thanks you so much for joining us. Appreciate it.